All right, here we go, people. Backside of the review, number 8. Now, I know some people were probably confused by these, and I totally understand. We have not seen any at this point of these kind of graphs that have two separate things going on the same graph. Like, we would see, like, none of this. We'd see just the first part, or we'd see just the second part, but not both together. Excuse me. Sorry about that. My throat's a little dry. Must have been all the coffee I had this morning. Now, I'm just going to kind of fly through these. Here's the thing. For the test, you're not going to have to do any of this sketching of graphs because there's no way for you to do that on the test. It's going to have to all be multiple choice because there's no way I can have you sketching and writing things out for this thing. So I'm just going to kind of show you and try to quickly explain what's happening. So just follow along. This right here, this one, that, again, this is an XT graph, position time graph. That is a negative constant slope on this graph. Negative constant slope, which means negative constant velocity. Remember, the slope of this graph is velocity. Negative constant slope, negative constant velocity. How do you show that here? Negative constant velocity. Well, that's zero velocity. Those are positive. These are negative. Negative constant is down here like this. So, give me the pen. Let's remind ourselves that's zero, that's positive, that's negative. Right there. Next part. The next section, this is someone at this, whatever position this is, they're at that position and they are staying there. They are not changing position. This is zero slope. This is no velocity. No slope, no velocity. Staying at the same place. How do you show that here? On the t-axis. I hope that you were thinking about that. On the t... Oh no, what the heck just happened there? Yikes. Let's try that again. On the t-axis, right? Like that. Motion map. Oh boy. That means the first half, it's traveling in a negative direction, starting in a positive position away from the zero, traveling this way with a constant velocity. 2 arrows, the same length. And then what? It stops. Oh boy. There we go. Something like that. A equals 0. There's no acceleration. It's constant velocity and then it stopped. No acceleration. Next part. All right, we have to think about tangents, folks. Tangents. That's pretty steep, right? Steep positive. Steep positive is up here. That's fast, right? Fast positive is here. What's happening to this slope? Let's get to the midpoint. Halfway through this thing, how fast is it? That's level. That's zero velocity. Remember, zero's here. Positives are up here. Negatives are down here. So that means the line goes down like that. Now, I want you to look at this. What happens to the slope on the backside? I hope you're thinking about the pencil, like the pencil in your hand can be, if you have a pencil. You may not have a pencil. I hope you're thinking that the pencil in your hand is like a slopometer, where you can lay it across the curve like a meter stick or a stick on oh gosh, what just happened? Like a meter stick or a stick on a ball. You can roll it across. Oh no, oh my gosh. Whoa, 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 whoa. This is, oh geesh. I'm sorry, this thing is all jacked up. And so I hope you're seeing that on the second half of here, I hope I haven't lost you. On the second half of this thing, the slope is now negative. It went from positive slope to no slope to now negative slope. That means it went from positive velocity to zero velocity to, you guessed it, negative velocity. So this thing has got to keep going like this, like that. Now, I want you to notice something here. Now, we have not seen anything like this, okay? And there probably won't be something like this. I shouldn't even have put this on the review, but I did. I'm sorry. This is positive velocity. This is negative velocity. See, negative? That means that's positive direction. That's negative direction. What happened up here? The direction changed. The slopes went from being positive on this side to being negative on this side of the curve. So this thing was slowing down positive until it stopped. Then it started speeding up negative. Oh boy. Whew. How do you show that in a motion map? Well, where did the object start? Start at the 0 position. How do we know that? Because we can look at this right here. Where is the y-intercept on the position time graph? It started at the 0 position. Just like this one started with a positive position. This one started at the 0 position. And it was going very fast at the beginning. Then it slowed to a stop. Then it sped up in the other direction. What does that even mean? Okay, this right here. Just follow with me. Okay, you're not going to have one like this on the test. Just trust me. It's okay. It's going to be fine. Fast, and then slower, and then slower. And then what happened? Then it started speeding up, but the other way. Now, I didn't expect you to know that. If we had been in session together at the school building all of this time, you would have had an assignment that had some of these on it, but I didn't even bother. Since we weren't able to meet together, I just didn't even bother putting that. So, yeah, no worries. Don't fret about it if you don't understand these. All right, I'll tell you once we finish this last one. I'll tell you what's going to happen. I probably shouldn't even have bothered going over it. I'm sorry. This right here. What's this? This is an up curve, okay? An up curve, meaning it starts with how much slope at the beginning? Like none. That's a loud bird. It starts with like none at the beginning. It's horizontal. And then what happens to it? It gets steeper as it goes. So that means it starts with no velocity at first, and it gets steeper as it goes. It gets faster as it goes. Starts with none and then gets faster positively, because that's a positive slope. Okay? Starts with none. 0 because it's horizontal. Not because it's at the 0. That's just the position. The steepness tells you how fast. So 0 steepness, and then it increases steepness positively. Positive. Now the second part over here, it looks like it's linear. It looks like a straight line. It looks like it stops curving when it gets to this part. If that's constant velocity, how do you show that here? Constant velocity is horizontal like that. It doesn't go up anymore. It was getting faster, and then it stopped getting faster. Oh gosh. There. Right there. Got that? Oh boy, I'm sorry. I shouldn't have had you do these. I forgot these were even on here. All right. Next. Now they got the motion map. Started at the 0 position. How do I know? Because of that right there. It had a 0 y-intercept right there. Traveling in the positive direction and getting faster, meaning it wasn't going very fast, and then it got faster and faster. And then what? I should have... Yeah, that dashed line's in the wrong place. Should be like out here. And then what happens? Then it just maintains. It keeps going the same. Oh crap, you know what I realized? We didn't do the A on the previous one. In this case, A is positive here on this side. On this side, A is 0. How do I know that? Look at this graph. That's a positive slope, right? Positive acceleration. What kind of slope is this? 0. What kind of acceleration? 0. It's not getting faster or slower, no acceleration. Getting faster, in this case, to the right, that's positive. Here, we didn't put the A. I forgot to put the A. Now, this right here has what kind of slope? That's a negative slope the whole time. Negative slope, which means our A down here, our A has to be negative the whole time. Now, what did I just say on that previous one? I said that the A is always going to point in the direction of the longest arrow. Look up here. The longest arrow is on the left side of the motion map. A is to the left. The longest arrow is on the left side of the motion map. A is to the left. So this is, even though this object changed directions, it was going to the right and then stopped and then went to the left, the A is to the left the whole time. The A was making this slow down this way, and then it was making it speed up when it went the other way. So it acted against the motion when it slowed it down. It acted with the motion when it was speeding it up. Hope that makes sense. I don't know if it will or not. All right, finally, we're going to get to the last part. Finally. Okay, last part. Compare the behavior of the two objects. Make sure to explain how you know. All right, which one has a changing velocity? All right, which one has a velocity changing? I hope. Now again, look at what's happening. This is a position time graph. So which one has a changing velocity? I hope you're saying B. How do you know? Because what? It's a what? It's a curve, right? The slope changing slope. That's key, okay? You know B has to have a changing velocity because it has a changing slope. B, which one is further at 1 second? Well, I don't know where 1 second is, but if that's 3, then that's probably about 1, and that's probably about 2. Would you agree? 1 there, 2 here. So, if that's the case, which one's further at 1 second? Well, let's take the little dashed line. Oh my gosh, A isn't hardly anywhere yet. B hardly isn't anywhere yet. A is all the way up here. So who's further? I'm going to say A is further. How do you know? Higher on y-intercept. How about that? That's how we know. How do we know that A is further? Because it's a higher y-intercept. It's up there further. Which one is further at 3 seconds? Well, at 3 seconds, it's right over here. Boom. Oh, wait a minute. They're what? Same place. Neither. Oops. I can't write. Oh, gosh. I still can't write. Neither. At same place. They are at the same place. How about that? Oh, let's see. Oh, how do we know? Because they're at the same place on the y-intercept, the y-axis. Same place at the y-axis. Now, which one is further after 3 seconds? So all the time after 3 seconds, who's further? Well, B is further, right? After 3 seconds, B is further ahead. How do we know? Because it's higher on the y-axis. E, which one is faster at 3 seconds? Now, I probably can't erase this stuff. This is gonna, oh, I can. I gotta get some of that stuff out of the way. Now, which one's faster at 3 seconds? How do you know who's faster at 3 seconds? What about this graph? What about a position time graph tells us fast? The slope. The slope tells us fast, right? So in other words, what do you have to compare these two lines? How steep they are. So which one's steeper? At time 3 seconds, which one's steeper? Look how steep B is. If that's a tangent to the curve, that's how steep B is at 3 seconds. Is that steeper than A? You betcha. Who's faster at 3 seconds? B. How do you know? Steeper slope. I hope that makes sense. You can tell B is faster because it has a steeper slope, even though they're at the same place at the same time. I really hope that makes sense. Now, do they ever have the same velocity? Do they ever have the same velocity? If so, when? Do A and B ever have the same velocity? That's the same thing as asking, do they ever have the same slope? Which is the same thing as asking, are they ever the same steepness? Do they have the same steepness ever? Yes. When? I don't know, but it's about when that happened right there. Look at my tangent there. Now it's not perfect, but that tangent is about the same steepness as A. Would you agree? When is that happening? Well, about right there, about 2 seconds maybe. Maybe at 2 seconds they have the same velocity. So yes, they do. When? 2 seconds-ish, maybe. It's when the curve steepness matches the steepness of A's line, which is right around 2 seconds, I'd say. I hope this makes sense. What you're going to have to do for the test, you are going to have to be able to look at graphs like these and interpret them. You're going to have to be able to tell what kind of motion is happening, what direction objects are traveling. So I don't know, maybe you're going to want to look back at some of the videos that I've posted up to this point. But the test will be all multiple choice, and it will be a Google form. And yeah, I hope that you all will spend some time looking through all of this old stuff and making sure that you know what's going on. If you have any questions, please contact me about it, and I can try to help you out. But the test will be posted on Monday and needs to be done on Monday. So, hopefully, I'll see y'all around here at some point. Maybe I'll see you at a Zoom meeting coming up here. We did decide that I'm going to start having Zoom meetings regularly on Fridays. And I also found out, see, I emailed you the link to the Zoom, but apparently I had said that I was going to post it on Classroom, and I didn't. I just emailed it instead, and apparently some people didn't get it because they didn't look at their email, but they were looking at Classroom, waiting for the link, and so I apologize. That's my fault. I should have put it on Classroom and emailed it both. So anyway, hopefully I'll see y'all at some point soon. Take care of yourselves, and we'll see you hopefully later.